welcome to today's webinar. We're just gonna wait 1 minute for a few more people to trickle in. Just 1 minute. We're gonna start at like 9:01 a.m. Pacific Standard Time. But I really appreciate everyone joining. I know everyone's in different time zones. It's late, it's early for some folks. But we really appreciate you taking the time to join this webinar. Oh, it's 9:01. All right, perfect. Well, let's get into this. So hi everyone. My name is Chris Dabatos. I'm actually the developer advocate here at TiDB. And so again, I want to thank everyone for joining us today for our TiDB AgentX Hackathon webinar, where you'll learn how to build your own things using TiDB, Kimi, and Sheet Zero. And the hackathon this year is all about it's all about pushing the limits of AI agents and real world workflows, right? And so that's why today we're gonna walk you through how you can quickly get started by building your own apps with, again, TiDB, Kimi, and Sheet Zero. But before we dive in, let me introduce today's speakers. So first we have Feihu Tang, who is the head of developer relations at Kimi. And so Feihu actually brings deep expertise in AI systems and developer ecosystems. And Feihu is going to show you how K2's open source model can help analyze local multimedia files and connect them to TiDB Cloud. And then next up, we also have Yanshu Wang, who is the head of algorithm engineering at Sheet Zero. Now, Yanshu actually leads the development of AI-driven agent technologies that actually make data processing smarter and more autonomous for you. So he'll be showing us how Sheet Zero agents can actually navigate and understand data requests in a way that kind of feels almost anticipatory, right? And then finally, I'll be sharing something as well on how to build your own semantic Q&A app. I'm actually going to share an app that I built while I was on a plane ride from Las Vegas to Austin, so that'll be interesting. But yeah, so we're going to go step by step, keep things simple. And yeah, I guess I'll go ahead and I'll go first with my quick demo. So let me just share my screen really quick. Um, Sorry, 1 second, it's not sharing. All right, let me share this. Can you see my screen? I think you can now, right? Yeah, you can. Okay, cool. So let's get into this. Make sure I can see mirror this on my side. Okay, so again, my name is Chris Dabatos. Everyone, thank you so much for joining today's webinar. I do developer relations here at TiDB. That's my LinkedIn account. If you want to add me on there, I appreciate it because I like more people knowing about me and I like being popular. So if you want to follow me on LinkedIn, go ahead. I'm not going to stop you. But a little interesting fact about me is that I've actually have been doing YouTube myself for like the last, I think, 10 years, where I actually vlogged my journey from living in my car to getting my first software developer job and then being where I am today. So, and other than that, I've been in tech for nearly 10 years now. So it's been great. It's been a great time so far in tech. Despite AI being here, it's been actually even better now, better than ever. So anyway, let me go into my talk. So today, the title of my talk is meaningful answers, not keyword matches. Okay, meaningful answers, not keyword matches. I can't see the chat right now, but I'm curious if anyone's actually ever seen this painting before. The reason is because this painting is very interesting. So this painting is called Magritte's Pipe. And Magritte, he drew this painting for a particular reason. Why? Well, if you look at the text under the pipe here, in case you don't understand what that means, I didn't know either. I had to use ChatGPT for that, like we do for everything. But that actually says this is not a pipe. Hold on, Chris. What are you talking about? What do you mean this is not a pipe? It's literally, it looks like a pipe that I used to smoke. What are you talking about? Well, what he's trying to imply is that just because this looks like a pipe doesn't mean it's actually a pipe. Actually, this isn't a pipe. This is painting on a piece of paper. That's literally what he means. This is painting on a piece of paper, right? But pretty much he's saying just because it looks like a pipe, just because it looks like a painting, doesn't mean it's actually a painting, right? And so I like to say I can say the exact same thing when it comes to the search box on the documentation websites we have at all these tech companies when we try to use our technology. Just because it looks like a search box does not mean it's actually a search box. right? I'd say that these search boxes on these documentation websites are more about like, they're more about matching text, matching letters, not meetings. So that's why over the next 14 couple minutes, I actually want to show you how I built this problem, how I fixed this problem using Amazon Bedrock, TiDB Cloud, and with just a couple lines of Python. So I'm really excited to share this with you. Let's get on to the next slide. So now, why is this so important? I think that's a question we have to ask, right? Here's what the research tells us, and here's the cost of bad search. So TSIA says that as many as 60% of support tickets are already answered in the FAQ. Imagine that. The support tickets that you might receive at work as a software engineer, most of them are already solved in the FAQ or the documentation of your websites. But why can't they solve most people's problems? They can't solve most people's problems. Why? Because keyword search has a limit. Keyword search can miss their synonyms. There can be typos, new phrasing, you name it. Like, for example, let's say I'm using MySQL and I want to learn more about how to do change data capture with MySQL. Well, I go to the documentation website, but let's just say instead of change data capture, because I don't like to type that much, I type CDC instead, this is just an example, it's a dumb example, but let's just say because I type CDC, not change data capture, I can't find all the things I need to use change data capture with MySQL, right? So then what should our goal be, right? Our goal, when we have these documentation sites or whatever, is to have one correct answer, type any wording, even if there's a synonym, typo, phrasing, problem, whatever, you name it, you get your answer and you get it within 100 milliseconds. Now, I know this is interesting. I think it's interesting. But now the question is, how do you build that under real world constraints? Let's say airplane Wi-Fi, which I did. So actually, when I built this, I was looking at homes to buy. I was trying to buy my first home, and I was looking at homes in Austin, Texas. And in Austin, Texas, it's a 6 hour flight from where I live. And so when I was on that plane for 6 hours, I was using Delta Wi-Fi. And while on the plane, I built this app. And so because I had some constraints, I just stick to three pillars, which is have no local GPUs, which means like heavy lifting needs to stay in the cloud. Yes, even when I use spotty Wi-Fi, I depend on the cloud, which means my laptop needs to send as little JSON as possible. Right. Number two, if no one's querying, cost drops to zero. And number three, every call logs plain JSON so I can debug from the trade table because I don't have the best internet access. So keep this in mind as we zoom into architecture. So I'm gonna go through this really quick. Next, we have what we call I call the four-step pipeline, or you can call this the four hops. And let me go over this real quickly. So here's the whole flow in one breath. How we go from question to answer using semantic search with AWS Bedrock and TiDB. So step one, a user types a question in the CLI or React UI that I created. Step two, a tiny Python helper sends that text to Titan v2 and gets back a 1024 dimensional vector. Step three, we store that vector plus the raw Q&A in TiDB serverless, which is indexed with Avia flat. And then step four, at query time, we embed the new question. We run order by embedding. And then TiDB returns the closest match. Now, what I love about this is that you have no service to babysit, right? Zero costs while idle and answers land well under 100 milliseconds. So now that we got the bird's eye view of how this all works of this app that I built, let's zoom in on the actual embed section, right? Step two here, and see why I chose Bedrock for this in particular. So why Amazon Bedrock? Why do you use Titan V2 embeddings for this? So first of all, quality. So Titan V2 scored a 57.5 on the MTEB re-rank benchmark, and it also handles 100 plus languages, which is perfect for FAQ work. And because it's AWS native, you get everything from IAM, you get CloudTrail, KMS, the AWS basics are baked in, so we never touch the raw models, and it's incredibly cheap. Like it's insane how cheap it is. So it's about 0.02 per thousand tokens. Let's say 2 cents for a million tokens, or if you have 20 bucks, that'll buy you a billion tokens. By the way, with TiDB Cloud, if you use Titan V2 embeddings in our integration section, you actually get $25 worth of free credits with AWS Bedrock with which is baked into TiDBCloud.com. So check that out. Anyway, so that handles the embeddings. Now let's see where we store the embeddings. Let's see where we store the embeddings. So on the data side, we use TiDB serverless, aka why you here, why we have this webinar, we have the hackathon. But I'm really curious actually if while I give this talk, if anyone could share in chat if you've ever heard of TiDB before, or if you haven't, please please let me know in chat. Yes or no, that's all I need. And don't be afraid to hurt my feelings, okay? But anyway, TiDB serverless, if you don't know where you are, is a well, we're open source, but we're also a TiDB Cloud or TiDB serverless is a fully managed MySQL compatible cloud database that is actually designed to overcome MySQL's limitations when it comes to scaling analytics. So we actually are great at that with TiDB. And with TiDB, you have the ability to auto scale or auto shard from zero, which just makes it much easier on your end. And guess what? We only charge you for the compute you use. Okay. So I'm sure a lot of you already know what TiDB is. I don't want to spend too much time on this. But when it comes to vector embeddings, what you do have the ability to do is you do get native vector columns. Pick any dimensions. I use 10 to 24. You get IVF flat, H and SW indexes, and you pay for what you use. We also offer on our TiDB starter plan, you actually get the first 5 GB are actually free. Then it's just 10 cents per vCPU hour as load grows. Oh, nice. So a lot of people, quite a few people have heard it, and a lot more haven't. Which I totally understand. Which I totally understand. Thank you for answering my question. Now, okay. So now let me show you the 7-line helper that actually glues Bedrock to TiDB. And again, at the end of this talk, I'm going to show you my GitHub where you can clone it and do whatever you want. All you have to do is update your credentials. You'll be able to do exactly what I show you in a couple of minutes, actually. So first, this is the Bedrock call-in-one function. The first 2 lines here, grab the SDK and make a Bedrock client. Nothing fancy. Then next, we package the user's text and we tell Bedrock which Titan model to use. Then I have one API call. Okay, one API call. Again, this is just a personal project and just show you an example of how you use TiDB for vector embeddings. But one API call, which is where Bedrock gives us back a 1024 float vector. I hope this is not blocking it. Is Zoom blocking the screen for you? I hope not. Let me just move this. There we go. It's blocking it for me. All right. Where was I? All right, and the last two lines is where we parse a JSON and return the vector, and that's it. So it's just the simple 13 lines of Python to call to call Bedrock in one function. So what you just seen is the call we used to get Titan embeddings. Now let's actually watch the whole chain fire. So I'm going to show you a quick simple CLI tool that I made. Let me get out of here. This is probably too small, huh? Let me make this a little bigger for you guys. That's the biggest I can make it. Sorry. But anyway, let me just show you the app that I built. So this is the CLI tool. Again, this will be in my GitHub repo, which I'll show at the end. So this is my simple CLI tool. This can't get any bigger, huh? And what I'm going to do is I'm just going to ask a simple question. Show you a simple question. Actually, before that, let me show you my Visual Studio Code real quick. So on here, I have 200 objects, right? Questions and answers. I use ChatGPT to make this, but yeah, 200 questions and answers in here. And what I'm going to ask is just simple, not even a question. I'm just going to type 2 words, refund timeline, and let's see what this does. Okay, cool. So this is just from a cold start. So it took a total of 8.126 seconds to get the answer. I typed refund timeline, and what did my semantic search app do? It found the closest stored question, which was when will my refund be processed? And the answer, refunds are issued within 5 business days after the return is received, right? So it found the closest stored question to whatever I need. Let me ask another question. And actually, before that, I'm gonna open up my Visual Studio Code, and here you go. Here's the word Philippines, right? I'm in the JSON file. Nothing's popping up in the Philippines, right? I just want to show you on that sheeting. What I'm going to ask next is, do you ship to the Philippines? Do you ship to the Philippines? And let's see if it understands my question. Okay, so after the cold start now, total time to get the answer is 0.3451 seconds. So I asked, do you ship to the Philippines? And what was the closest stored question it found? do you ship internationally? So what's really cool is I didn't need to ask, do you ship to another country? Do you ship outside of the United States, which is where I am? I just asked, do you ship to the Philippines? And I understood the intention, the reasoning behind my question. And they gave me the answer, yes, we currently ship to 35 countries worldwide. And this time it gave me an answer much faster after the cold start, right? And it's because Bedrock's already warm. So what we saw here is that we got two totally different phrasings, no keyword overlap, and both answered correctly in well under a second. Now, where does the data land? So I'm actually running out of time, so I'm gonna go through this pretty quick. Where does the data land? Sorry, how do we fetch the best answer? I mean, so well, let's look at this first, right? So how do we define and populate the vector table? So the client you saw fires 2 bits of SQL, right? The create table statement carves out a home for every FAQ. It stores a raw question to answer in the vector 1024 column for Titan embedding. Oh, then right after that, we have the create index command, which adds an IVF flat index on that vector column, sets to 100 lists with coincide distance. So similarity look up, stay fast, and the table grows. Now that we look at this, how do we fetch the best answer? Well, pretty simple with one line of SQL. Well, not one line of SQL, but single query retrieval, right? So fetching is one line here, pretty much, where you sort rows by coincide distance to the query vector and return the closest match, right? So I know I have about 2 minutes. So I'm going to share one last thing. I want to actually show you my UI app that I built for you. So let me just Python run or Py. So this is the UI app I built. It's just in basic React. Let's just load real quick. All right. So this is the UI app that I built, and I was going to ask it 3 simple questions. I want to ask it 3 questions to see. I want to ask it 3 questions to see the results we get. So I'm going to ask first of all, which is when will I receive my refund? Cool, so it's working, thankfully, because this is a live demo. Refunds are issued within 5 business days after the return is received. Then just one question I'll ask, one more is, I'm not going to use the word refund. I'm not going to use the word money or dollars. I'm just going to ask, when will I get my money back? Boom. So I asked 2 different questions, right? When will I receive my refund? When will I get my refund back or my money back? And then still understood the intention of my question, gave me the exact same closest stored question, an exact same answer, and that's semantic search. That's semantic search. Oops. And so I'll actually put this in chat as well. This is my GitHub repo, right over here. If you want to clone that, I'll put the link in chat right after this. But this is my GitHub repo. This is the repo to TiDB if you want to get a few more free credits. But anyway, that's my talk on how I built a semantic Q&A app. If you have any questions, please ask me in chat. Cool. Okay. Whew. I did it just on time. All right. I had to do the introduction and then still give my talk in 15 minutes. So yeah. Okay, cool. If you have any questions, let me ask me in chat and I'll get back to you. Next up, will actually be Yanshu from Sheet Zero. So Yanshu, please go ahead and take it away.
Okay, okay. Hello, good morning, everyone. I'm Yanshu Wang, head of AI engineering in Sheet Zero. I'm excited to introduce Sheet Zero. This is a breakthrough in intelligent alpha data collection. It transfers how organizations gather and process web data. Um, let's wait. Okay, let's start with a simple demonstration. Imagine you tell a system scraping the companies in the last batches and you get these results. Traditional approach would could require weeks of developments. You need to build a scraper for website. You need social media APIs and some analysis pipelines. Maybe you need some data corrections, but with sheet zero, uh, business users can simple state this goal in natural language. Our system can automatically complete this entire workflow in minutes. Our agentic AI architectures power these complexities. So specialized AI agent cooperate together. They understand the compete goals and decompose the goals into sub goals and hand off the sub goals to sub agents. And I will introduce our our sheet zero and some design philosophy for multi-agent system. Let's let me outline the foundation challenge in data collection today. At first, the problem is very hard. Traditional web scrapers use hard-coded rules and CSS selectors. Websites update their design constantly. This These scrapers break when the website design changed. Industrial studies show a clean pattern. This creates an unstable maintenance burden for the organization. The second is the complexity barrier. Each new data source requires custom development. A typical enterprise data collection project involves multiple data. You need uh, web developer to build the scraper and the data engineer to design the pipeline. Or you also need an analytics to structure the output. The process often takes weeks or months for each data source. The second challenge is the scaling challenge. Modern data requirements are increasingly complex. Users don't want just one page extraction. They need multi-step workflows. Those workflows must navigate a complex user interface. They must correlate data across multiple sets. They must adapt to dynamic content. Current tools simply can't handle these requirements reliably. The last challenge is expertise gap. There is a fundamental disconnect in most organizations. For example, business analytics only understand the data need, and researchers may also understand the data need, but they can't implement technical solutions themselves. Technical teams can implement solutions, but they don't always understand the business requirement. So our sheet zero addresses this challenge. We use intelligence automations and adaptive execution, and we only need the user to input the nature language. Let me show you how sheet zero delivers values across different cases. For example, we can use it at business intelligence. Some company may use sheet zero for com competitive analysis. They can track a computer's price across multiple e-commerce sites. Traditional approach would require months of development. With sheet zero, they simplify the monitor pricing for our top products across major sites daily. The system delivers the data in minutes. And the second is academic research. The researchers may need trial data from multiple regular websites, and manually collection would take months. Zero can automatically navigate website and extract structured data. And there are also some other applications. Next, I will introduce the multi-agent architecture for some agent design. Mm, at first, I will introduce why we need to use multi-agent instead of single agent, because traditional approach use a single agent model, and the one agent will try to handle planning, execution, error recovery, and reflection simultaneously. This create a very heavy burden overload for this agent, and the reliability will decrease. So if we have multiple agents, each agent will have a specific task, and this approach will be have high reliability, like the picture in the left. Mm, um, we can also use layered multi-agent system like this. In the layer one, we may have a master planner agent. This is a core master agent, and it can decompose the task to subtasks. And layer two, we have some sub-agent like in our case, we have URL suggestion, flow control, navigator, data analysis, and you can design the sub-agent according to your application. And layer 3 is a domain-specific agent. It can have many cases. For example, for finance agent, we may fine-tune a model for this case, and others the same. For example, in layer 1, the in layer one, we have the master planner. The planner decomposes natural language goal into executable sub-goals, and it creates flexible sub-goals based on the prompt. Those sub-goals can handle sample data extraction. They can manage complex multi-step navigation. And besides this, the planners can do some reflection. The reflection, after each execution, the planners validate the results and it can correct the planners according to the execution results. And maybe some human AI collaboration is needed because the agent may occur some boundary and restriction. In this case, it can stimulate require human input. User receive con contextual questions. They can provide guidance without interrupt the overall workflow. And layer 2 is some specific execution agent. In our scenario, we have URL suggestion flow control agent and some navigating and scraping agent. This sub-agent can be redesigned according to your domain. And layer 3 is some domain-specific intelligence, and this layer may need many data to fine-tune and to fine-tune. Besides the layered multi-agent system, the agent should be cooperating and learning. First, it should be continuous learning. Early successful execution generates training data for the model to improve. We collect the interactive patterns and use a pattern to retrain the model. The second is data-driven enhancement. Our multi-agent approach enable target model improvements. Planning model learn from some successful workflow decomposition, and navigation model may improve through efficient web interactive pattern. And as this create a circle, the system can become more capable over time. It can learn from each successful execution to improve the future performance. And this is takeaway. First, using our system, you can easily collect the data from the website with automatic goal-driven collections. For second, you can use the multi-agent architecture to design your own multi-agent system. Third, uh, our system can input the natural language and transform the complex data collection task from weeks to minutes. Uh, Thank you. Uh, do you have some questions?
Awesome. Thank you, Yanshu. Does anyone have any questions? Um, Please ask in chat. My slides, yeah, I can paste my slides up here in a second. Yanshu, can you actually is it okay if I share your email in chat? So if anyone has questions, they can email you as well.
Uh, okay, I can you.
Or for those who are trying to get
Okay,
um
I send my email to the chat.
oh, awesome, thank you. So yeah, there you go. There's a Yanshu's email. So please make sure to email him if you don't have any questions yet, but you do later. I'm just pasting the link to our Discord, TiDB Discord. But you might need to join that before you can get free credits with Kimi. Awesome. Thank you so much, Yanshu. Next up, we have Feihu from Kimi. So please go ahead, Feihu. It's all yours.
Hello. So, okay, this is Feihu Tang from Kimi.ai. So basically, we are a large language model company in China. I am the developer relationship of Kimi.ai. So today I'm going to introduce some stuff of our platform. So first, the most important thing is how to redeem your team API token of our model. So basically, you need to join the Discord channel first and find the sub channel, and you can just leave your message about your team, and our contributor will go to reach you and send you the redeem code. And once you have the redeem code, just open our website and find the voucher and click here to enter your code. So okay, the important things is you must be aware to use the .ai URL, not the .cn URL. They are different database. So if you are call this model from and change the base URL, you need to be aware of the difference. So second thing is how to use our most powerful K2 turbo model. This is the newest model of our company, and it's faster and a little bit expensive than the preview version, but you have enough API token, so I think it's good to choose the turbo model. So basically, you need to change the model item in your API call and use the Kimi K2 turbo instead of the preview model. So, and nowadays, the web coding is everywhere. People not only use the large language model to build their production, but also use the language model to during their development. So remember, you can not only use our model in the production, but also during the Hackathon event. So it's something like a server bullet. And there is a report about the AI coding adoption. You can see it's very fast. And some even use web coding during their interview. So, and if you want to try web coding during your Hackathon event, you can try to use several AI IDE tools such like the Cloud Code or Cursor. You can change the model base URL to use our K2 model instead of their model. And for example, this is the ByteDance tree IDE. You can use K2 model by default. Okay, cool. So what kind of the web coding you can build? Here is an example. So this is some guys building a interesting app in Tweet. So basically, you can see there is 3 buttons on the screen, and once you use your hand and try to switch between different music. So this can be done by just a few prompt if you use the web coding. You just tell the model what you want to build, and everything will be done. And there is some live model during our past event. This is last weekend during the Beijing Hackathon of our event, and you can see some of our talent develop just use web coding to build their app. And this is a virtual computer inside the website, and there is lots of apps in their virtual computer, and even there is a small web browser. All of these stuff are building directly by your prompt. And once you decide to use your web coding, and here is some best practice you might need them. So first is how to be cheaper and faster. So tip 1 is using cache. So the long context with caching is something if you have some resource or article and you catching them, and once you can ask different question based on your article, and you can get the answer, and that will be cheaper. So it's not only can save your money, but also can save your time. It can save the token of the time of the first token extremely. So there is a best paper award of this technical. You can read this article for the detail. So the second one is the compressing and prompting. So the compressing, if you are building some difficult and large, huge app, you might use compressing to compressing your token. And there's lots of good example. For example, the cloud code, the best practice is to use the cloud code markdown. So the basically is to summarize your information of the code base. So it's a kind of the compressing technology. And another one is some DeFi and the codes. You can use the knowledge base. It's basically some kind of IIG stuff. You might know that in our past year hackathon. So also during the Google SDK, you can have the IIG SDK. And there is lots of technical stuff of the IIG. This is another example of the compressing. The third one is the parallelizing. So there is a lot of method to use parallelizing. So there is some best practice. For example, you come up with you need the model to come up with several methods to solve one problem, and you choose one of them, and this is completely parallel agents, and you can use the parallelizing technology to resolve this. Not only you can use these TMUs or open mode terminals, you can also build a blueprint and or roadmap based on your workflow dependency, or build a multi-agent system. That's our topic of this event. And for example, it's a blueprint of the Lean examples, and you can see some of the tasks are completely irrelevant, and you can process them simultaneously. And here is another example. It's a project building our last hackathon event, and some students build a AgentX factorial based on our large language model. And here is a small video of their product. So basically, each small car is controlled by a language model agent, and they are working together to deliver stuff in this factory. And in fact, this is a real-world example of how to build a multi-agent system. So maybe it's also, you can find the example on GitHub if you want some reference. So this one is getting the first award of our last Hackathon event. So the last one is a structured prompt. So basically, the output must be in a straight JSON format, and the language model will always surprising you. So if you have read some code of the GitHub, you can find lots of them, and they are inside the brackets. So there's lots of method to adopt this tip. So first, you need to a specific prompt rather than the vacuum one, and you can ask the model to output JSON, the XML, or other script language, and you can use tool calls or building your tools by yourself. So because this is a structured prompting and being built in the language models, and you can have build a MCP server. It's also a best practice. So basically, it's some of the technology we used during our last events. So that's all. Happy hacking and have fun. I'm inside the Discord channel. If you have any question, feel free to mention me. Thanks.
Awesome. Thank you, Feihu. Great talk as well. Someone actually asked a question in chat about the free tokens that Kimi is offering. They ask if you're providing API call access with Kimi. Are you able to answer that question, Feihu?
Pardon?
They're asking if you provide the ability to do API. They're asking if you're providing API calls because this particular person needs API calls for their project. I'm assuming yes, right? Since you're offering free tokens.
Yes.
Yeah. Awesome. Thank you. And is the only way to get free tokens with Kimi right now, is that through our Discord channel, in TiDB Discord channel?
It seems that some people are currently doesn't in our Discord channel at this moment.
Yeah. But yeah, they're just asking how to get free tokens, and the only way to get free tokens with Kimi for this hackathon is through our Discord channel, right? Is that correct?
Yes.
Okay. Yeah. Sorry, for those who are trying to add me on LinkedIn, you can email me at chris.dabatos@pingcap.com, and I'll just email me your LinkedIn account and I'll add you. Where's the hackathon again? Okay, yeah, let me get the link to that right now. So here's the link to the hackathon for those who haven't seen it yet. And the link to Discord is on that actual hackathon website. Does anyone have any more questions for me or Feihu or Yanshu? Oh, actually, there were some questions in the Q&A section. Let me pull that up real quick. So in our Q&A section, John actually answered you already. So someone asked, John said he was trying to implement vector search in his free tier cluster, but it seems to not support L2 distance and function. And then he asked, can I please confirm if he is required, if he needs a dedicated cluster to implement full vector search? And so, John, just in case you didn't see this in there, the question answered, you shouldn't need a dedicated cluster for this. Our TiDB starter, our free tier, actually supports vector search with L2. You just have to make sure you're calling VEC _L2 _distance, and that your vector dimensions match. I hope that helps. If not, email me. You can email me now. I'll try to get a better answer for you, or DM me on Discord. And then someone else asked, Manasa asked if there are any .NET C# SDKs for TiDB Vector. No, right now we currently only have a TiDB, aka Python SDK at the moment. Uh, any other questions? Just I'll give everyone a minute. But again, this video I will upload this to YouTube. There will be a transcript. Actually, YouTube automatically transcribes it for you as well. And I'll also upload links to get free credits for TiDB Cloud, TiDB Starter, and for Kimi as well. Yanshu, I don't think Sheet Zeros. Are you offering any free credits? I don't think so just yet, right? For Sheet Zero, are you offering any free credits for Sheet Zero for the hackathon?
Okay, sure. If you have, uh, 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 if you need it, I can provide the credits.
Oh, okay. Um, should they email you then? Should they email you for free credits, or do you want actually to make things easier? If you need free credits to Sheet Zero, please email me, and then I'll give your email to Yanshu directly. I'll DM him directly on Lark on there. Oh, there are a few more questions. Okay, what kind of framework are you using in Sheet Zero? Like LangGraph or LangChain if possible? Yanshu, yeah, Yanshu. So someone's asking, they're asking what kind of framework you're using in Sheet Zero. Is it LangGraph or LangChain? Is that possible?
We haven't support the launch with Sheet Zero. It can only use in the website.
Okay, only currently using the website right now. Okay, okay, awesome, cool. Any more questions? Again, if you want free credits to Sheet Zero, just send me an email. I'll post this in chat again. Let me just post my email there. And then I'll send all the emails to Yanshi so his email box doesn't go crazy. I just shared my email right there, John. Yeah, please email me if I didn't answer your question correctly or anything, please just email me and um yeah, I can help you again there. Cool. Any more questions? Going once, going twice. Oh yeah, wow. Just in time. So what Okay, what is the different what's the difference between TiDB vector with other vector databases such as Redis, or I guess you can say with other companies out there? That's a good question. So with TiDB, when it comes to vector embeddings, you actually have the ability to store your vector embeddings and your business data in the same database. Where, for example, let's say you use another company for vector embeddings, and then you use Postgres, PG Vector, or no, sorry, you use Postgres database. Well, then you need to build an ETL pipeline together to connect your business data and your vector embeddings data. But with TiDB, you can do it all at once. On top of that, you get auto sharding, so it's very easy to scale horizontally. Good question, though. Cool. Okay, anything else? Are we able to use TiDB to analyze bank statements? We do offer, you have the ability to do analytics with TiDB, but to do that, I'm assuming you just have to do some programming with some LLM on your end. I'd recommend open source LLM. You don't want that data up in the internet. Uh, how does it train based on database data or from Google search as well? Do you mean like when you scrape data? So I'm actually working on a particular project where I'm scraping all of our docs and data on TiDB on PingCAP.com and getting answers to my questions based on all the issues that we have and issues that we've resolved. So maybe that helps. Does TiDB support hybrid search? We kind of do. I did create a hybrid. You mean hybrid of like full text search and semantic? Is that what you're talking about, Naveen? So here's some examples actually. I'm gonna post in chat, please, because this call is gonna end in like a minute or two. So here are examples of all the things that our engineers have built that you can clone yourself, and that includes, I believe we have a hybrid version on there. Yeah, we have hybrid search on there actually under search and retrieval. So make sure to check that out, please. All those examples below, I think will help you out a lot. But okay, cool. Anything else? Almost out of time. Okay, it looks like that's it. Okay, awesome. Well, Yanshu, Feihu, I really appreciate you being on. I know it's midnight for you right now, and so past midnight, actually 1 a.m. So I'll let you go to bed. Thank you so much for joining. If anyone has any more questions, please let me know, and I'll communicate with Feihu and Yanshu. Thank you, everyone. Have a good day.
Thank you.
Have a
Thank
good
you.
night.
Have a nice
Bye.
day.
Have a nice day.